in most of the programming languages, you must have. Okay, thank you for the starting the recording. So, in today's session, we shall be studying about list, set, tuple, and dictionary, the very important data types or the data structures available in Python. So, in most of the programming languages, you must have studied array, and whether it is C, C++, or Java, we all know what do you mean by an array. An array is a collection of elements of similar data type which are always stored consecutively in the memory. So when we have a setup like that, in which the entire collection of elements, that collection is of single type, and then all the elements are always stored sequentially or consecutively in the memory. So such collection is called as an array. Such collection is called as an array. Now in Python, when we talk about array, so array is not available as a built-in type. I repeat, array is not available as a built-in type. Instead, it is available through a module. Okay. So we need to import a module called array, and then we can use that module to make use of it. The very reason is that whatever you can do using array, everything, most of those things, and even more than that, you can do with the help of list. So array can be easily avoided in that case. So what is a list? A list is a collection of elements which can be similar or dissimilar. List is a collection of elements which can be similar or dissimilar. All these elements are separated by comma and they are enclosed in square brackets. I repeat, all these elements are separated by comma and they are enclosed in square brackets. Most often when we make use of list, so generally and most often we store the data of similar type. Though it is not required, you can store the data of dissimilar types also into your list. But most often we store similar types. So for example, when I want to create a list, suppose my list is L, so I can simply say L equals to, and then in square brackets, as I said you, the elements of the list separated by comma. So for example, 1, comma 2, comma 3, comma 4, comma 5. So this way I can have my list, and then the list has been initialized. So L is an object of a list class. Selection. L is an object of a list class, and if I want to display this list, I can simply display L. Now let me execute this code. So if you can see this, so yes, your list has been displayed as a list itself in square brackets 1, comma 2, comma 3, comma 4, comma 5. Okay. Now, since the list is a sequence, please listen the words carefully. Since the list is a sequence, so ordered sequence. Since the list is an ordered sequence, you can make use of indexing to access its elements. You can perform slicing also. I repeat, you can perform slicing also. What does it mean? With the help of indexing L square bracket 0, I can access its element. If I want to access the first element, I can write L of 0. And that would give me only the first element. Okay. Likewise, I can go for L of 1, L of 2, and so on. So this is my second element. And if I want the last element, then I can make use of negative indexing, -1. So -1 indicates the last element. So we get the last element. Okay. Now we can make use of slicing also. So instead of a single element, if I want more elements, for example, I want to start from the first element and I want to go up to say the third element, I would be doing like this. It is up to the second element. Whatever the end value we are specifying minus 1. So first element and second element 1 comma 2. Here I have specified 2. It starts from the zeroth index, and when I am writing at 2, so it is going up to 1 minus 1. So 0 and 1. If I want it to go up to say 3, so sorry, up to 2, then I would be writing here 3. So it would be displaying 3 elements now. 1, 2, 3. Okay. And the last is the step value. The first value is the start value, then the end value, and then the step value. By default, the step value is 1. By default, the start value is 0. So in slicing, what do we do? In square bracket, first you have the start value, colon, end value, colon, step value. Okay. So this is how we make use of slicing. Now this slicing is applicable wherever the collection is ordered sequence. Okay. So wherever you make use of the square brackets, there you can make use of slicing. Or in short, wherever you do indexing, there you can make use of slicing. Okay. So with the help of indexing, you'll be getting a single element. With the help of slicing, you'll be getting the collection of elements as per your choice. So for example, I want to go up to the last element. So I would remove this. So by default, it is last element. And I want a step of 2. So instead of, it will start from first element, and instead of going to the second element, it would directly go to the third element. And likewise. So you see the output, it is 1, 3, 5. Okay. So 2 and 4 are ignored because the step value is 2. So likewise, you can do the things. And suppose if I do not specify the start value, by default it is 0. So the output would remain same, 135. What if I make it minus 1? See here carefully. I'm making the step as minus 1. I'm not specifying any start value. I'm not specifying any end value. I'm specifying a step value as minus 1. Let's see what output do we get. Interestingly, we get this output, which is a reverse of the string, which is a reverse of the given list. So the list is 1, 2, 3, 4, 5. And when you simply do a slicing, wherein you do not specify the start value, end value, and you specify the step value as minus 1, so in that case, it would reverse it. So if I want to reverse a string, I can simply make use of this syntax. If I want to reverse a list, I can simply make use of this syntax. So very simple and straightforward. You do not need to write a code. So let me give an example. For example, if my string is IKTC over here, and I want to display the reverse of the string, what I would be doing as then in square bracket, no start value, no end value, and the step value is minus 1. Done. So this is the reverse of a string. Okay. That's why we say that Python is a easy programming language. You can avoid a lot of coding, and with the help of available features, with the help of available concepts, you can do easily quite big things. You can do easily. So this is the reverse of a string. You need not have to check. You need not have to put some logic or do some coding for it. You simply follow the slicing, and with the help of this kind of slicing, you can easily find the reverse of a collection. Now, likewise, when we are working on list, so one more thing about list is that list is mutable. It means that you can change the content of a list. String is not mutable, string is immutable. Now, since this is an ordered collection, ordered sequence, so we can make use of in operator quite effectively into this. What does it mean? That if I want to go for some value, if I want to check some value, For example, if I want to see whether an element exists in a given collection. So generally what we used to do in other programming languages, we start uh, from the first element, we go up to the last element, and then we keep on comparing the element one by one. Wherever we find a match, we stop there and we say that the element is found at this index value, and then we break the loop. Else, if the loop is completely exhausted, then we say that the given element does not exist. Now in Python, the entire logic is simplified with the help of in operator. So for example, if I want to check an element into this list, and suppose that element is say 10, I want to check whether 10 in L, then I would say print yes, else I would say print no. 10 is an integer value. A constant integer is written as it is into your code. So that's why I'm simply writing 10. Okay, so if 10 in L, L is a collection, which is a list. So I'm checking for 10 in L without any looping. Let's see what output we get. So the output is no. 10 is not present in L. If I change a value, for example, if I go for 5, whether 5 in L, so yes, 5 is there in L. Fine. So this is how it simplifies your task. Here we are not at all making use of any looping, anything like that. Simply we are making use of in operator, which can be used along with the if. So if a value in a collection. So if this is true, this in operator will take care of everything. It will compare this 5 with all the elements in the collection, and if it equals to any element, then this part is executed. If it equals to no element in the list, then the else part is executed. It is as simple as that. And likewise, if I want to check into a string, for example, I want to, now since I am specifying a constant string over here, so that should be in single quotes or double quotes. So for example, I want to check whether the AI in my string S. So whether AI is there in my string S. So yes, it says yes because AIKTC is my main string and AI is there in my string. If I say AIO, whether this string, this substring is there into my main string S. So the output is no, no. AIO is not present in your string S. Okay. So here also you can see the simplification of the code. You did not have to put a big logic over it. And this is, what we are doing. We are checking for the substring. We are checking whether the given substring is present in a string or not. So that entire logic is simplified so easily. If substring in main string, that's all done. If this is the case, then do your work, else do something else. Fine. So what happens here, the low-level programming, low-level coding is not required. Most of the things are readily available to us. So we can simply check. And that's why the language is also called as a very expressive programming language. It is something like we are simply saying if substring in main string. If this is the case, then do this, else do that. Otherwise, in other programming languages like C, C++, and Java, you need to check yourself whether that substring is present in the main string or not. And then you will be doing what you need to do. So basically, when you are finding whether the substring is present in the main string or not, so for that finding itself, for that searching itself, you need to write a code. And a lot of code is required over there. But in case of Python, that care has been taken by the language itself. So with the help of this in operator, a very powerful operator, a very small but a very powerful operator, you can do all those stuff. So now we can concentrate more on this part. Yeah, if the substring is present in the main string, then what I need to do? So I can concentrate more into this part. Or in general, if an element is present in a collection, if that is the case, then do something else, do something else. So list is mutable. You can change the list. And I think last time we have already seen what are the different functions available in the list class. So on my shell, I can list out everything of the list class. So list is a class, and then you can see after this underscore underscore, these are the methods of the class: append, clear, copy, count, extend, index, insert, pop, remove, reverse, sort. So all these operations we can perform onto a list. So for example, if my list is same one, comma 2, comma 3, comma 4, comma 5, then I can perform different operations. I can append to my list. So I can say L dot append. This will be adding the given data, say 6 at the end of my list L. So now if I display L, so I get this element appended to my list. And since a list is a collection of elements of dissimilar types, so I can have a different element over here, different type element, I mean to say. So now AIKT is also appended into the same list. So now here you can see that this here list wherein the data are of different types. The first few elements are of integer type, then you have a string, then you can have float, then you can have complex number. So it's up to us. You can have the list of your own objects. So you can have your own class, you can have the objects of that class, and then you can have a list of objects of those class. So it's up to us how do we need to implement it. But most often and generally, the list is used as a collection of elements of similar type. Fine. And it is mutable. That's why we are able to append. That's why we will be able to clear it. Clearing means your entire list would be cleaned. A lot clear. And if I try to display, then I get an empty list. So this is called an empty list. Now, if I want to append, I can keep on appending. And if I try to pop an element from the empty list, then it should throw me an exception. Let's see. Yes, an exception has been thrown, and the exception is index error, pop from empty list. We are trying to pop from an empty list. So that we can do, we cannot do. So let's append something into the list. So now there is one element, and if I try to pop, it should pop. So 10 has been popped. Now our list is empty. Yes, list is empty. If again I try to pop, it throws an exception. So these are all the methods which you can perform on a list. Likewise, the other collections are set, tuple, and dictionary. Now, let's move to other type. And before that, now we are displaying the entire list in a single printf, or sorry, in a single print statement by simply writing like this. For example, I got a list, say 1, 2, 3, and if I say print L, so it gives me the entire list 1, 2, 3. Now, if I want to get the list element by element, so I can make use of for the well in L. L is my list. Then I would say print well. Okay. So on different lines, I am getting different elements. This is my first element, this is second, this is third. Now these are element-wise access. Please try to find the difference. This is the excess of the entire list. So basically here you are getting an entire list, but here you are getting the element of a list. Okay. So what I mean to say that if I print the type of L, so of course it would be of class list. Okay. So class list. But if I try to print, okay, what is the type of the element at the 0th index, then it says integer, because that element is of type integer. So basically what I mean to say that when I trigger a command print L, I am returned with the list. But when I access the elements of the list like this for well in L and then printing the value, so we are getting individual values. Now it depends what type of values are stored into the list. If the values are of integer type, then integer values are returned. If the values are of float type values would be returned. If the values are of type string, then the string values would be returned. Okay. But the only difference that we need to understand is that when you print the entire list, so a list is returned, and when you print the individual element or when you access the individual element, so that individual element type is accessed, not the list type is accessed. Okay, so that is the important difference. The second type is tuple. Now, what is tuple? A tuple is also a sequence of elements, and this sequence can be of similar or dissimilar types. No issues into that. But this sequence of element is immutable. I repeat, this sequence of elements is immutable. Okay, so tuple is immutable. Now, how to declare a tuple? To declare a tuple, it is also a collection of elements. The data elements are separated by comma, but now instead of square brackets, we have parentheses. Instead of square brackets, we have parentheses. So, comma 1, say 1, comma 2, comma 3. So, this is my tuple T. And if I try to display T, I will be getting the tuple elements. Fine. And if I try to get a help on the content of the class tuple, so if you see here, so after your double score, this attributes, then you have only two methods associated with the tuple class. That is the count method and the index method. Why is so? Because it is immutable. Okay, you cannot change it. If you try to change the tuple, you'll get an error. So it is immutable. So you do not have any method which can write, which can update, which can delete the tuple elements. So you have only two methods, count and then index. Fine. So for example, if I want to see the help on count, sorry. So return number of occurrences of a given value. So it simply means that I would be saying t dot count. T is my object of the tuple class, and I want to search for the value, say 2. So it is returning me the number of occurrences of the given data element 2. So it occurs one time. If I try to search, say 5, which does not exist, so it says the occurrence is 0 because 5 does not exist in my tuple. Likewise, if I need to see what is the use of this index function. So it says that you need to pass the value, the start is 0, stop is the last, return first index of the value. So count will check the number of occurrences of the given value, and index would return the index of the first occurrence of the given value. Okay, return first index of the value. So t dot index, and say I want to check 3. What is the index of 3? The index of 3 is 0. It means that it is starting from index of 3 is 2. It means that it is starting from 0, 0, 1, 2. If I want to check the index of 5, now see here carefully. There is a value error if the value is not present. So it simply means that it would throw an exception if I try to find the index of a value which does not exist. So yes, it has thrown an exception, value error, tuple dot index x not in tuple. So only two methods in the tuple class. Tuple is immutable, so it means that if I display t of 0, so it gives me the first value. And if I try to do something like this, t of 0 equals to 10. So it says me tuple object does not support item assignment because it is immutable. On the other hand, your list is mutable, so we already have this L list. So what if I say L of 0? So L of 0 is 1, then I say L of 0 equals to 10. So if I do this, it becomes 10. And if I try to display it, so I get a 10 value because list is mutable. And if I try to do the same operation on a tuple, so that is not allowed because my tuple is immutable. Okay. So this is the main difference between your tuple and a list. Then the third type is your set. Now set is also a collection, ordered collection of elements of one type. And the important thing about the set is that your set does not support duplicate values. I repeat, set does not support duplicate values. It is the set of your mathematics. The way we have set in the mathematics, the same way we have that set in our Python programming language. So set is a class or the data type or the data structure in Python which does not support duplicate values. The duplicate values are ignored. You have unique value of every data element in a set, and they are always in a sequence. Okay. Uh, what does it mean? Let me show you. For example, I declare set, and for set, now tuple is enclosed in square bracket. Then, sorry, your list is enclosed in square bracket, tuple is enclosed in parentheses, and your set is enclosed in curly braces. So 1, 2, 3, 4, 5. And if I see the content of S, so it is 1, 2, 3, 4, 5. If I want to reinitialize it, and suppose I go for the values like this, I'm repeating the value of 5, I'm repeating the value of 6, and then I'm finally saying say 10. And if I try to display this as, so if you see the repeated values, the duplicate values are ignored because they are not allowed. So we, during initialization, we put 5 twice, we put 6 twice, but finally it has taken 5 only once and 6 only once. Okay. For example, if I reinitialize my S again with some new values, say 10, 1, 4, 2, 8, something like this. No duplicate values, or let me put some duplicate values also, 2, 4. And let's try to see the content of S. So if you see the content, so in the content, your duplicate values are removed, and at the same time, if you see carefully, so they are sequenced now. They are in order now. Okay. So you have the smallest element first, and then the next largest element, then the next largest element, then the next largest element, and so on. And what happens that if I try to say S of 0, so it gives me an error. Now this is very important. Please see it carefully. On set, you cannot do indexing. I repeat, on set, you cannot do indexing. Fine. Set object is not subscriptable. The term is what? Subscriptable. You cannot specify the subscript. When you write anything in square bracket, it is called subscript or indexing. So set object is not subscriptable. Okay, you need to remember this. So you cannot perform any indexing on a set object. Let us see. Can you tell me what's the reason for this? Anyone, please? Now, these are the methods which you can perform on the object of a set class. You can add two sets, and you can clear a set, you can copy a set into another, you can find the difference, you can find the difference update, you can discard, you can do the intersection. So all the mathematical operations that we perform on a set in mathematics, all those operations we can directly perform over here. So intersection, then intersection update, is disjoint, is subset. You can check whether the given subset is a subset of a main set. Then you can check for is superset, whether the given set is a superset of another set. Then you can pop, you can remove. And when you can pop and you can remove, it means that it is mutable or immutable. Yes, please. That is now mutable or immutable?
Mutable.
Mutable, yes. It is mutable because we can perform the right operation on the data set. Then symmetric difference update, union, and then update. You can perform the union, you can perform the intersection, then you can check for the subset, then you can check for superset. Okay, you can pop an element from the set, you can remove the element from the set. So you can perform all these operations. You can clear, you can add an element. For example, if I say s dot add, and suppose I want to add, say, 50. So now 50 is added. And then suppose I add up a value which should come in between somewhere, say 6. So let's see where the 6 would come. Okay, yes. So 6 is coming over here. Fine. And that's the reason you cannot do indexing, because it is going to, show the values in a sorted way. So the indexing or the subscription cannot be done because the values are not stored in sequence or in order. I repeat, values are not stored, not stored. And likewise, what I was supposed to do, s dot add, done. Suppose I want to check whether the given set is a subset. So s dot is subset of another set, and let me specify some set over here, 1 comma 2 comma 3, or 1 comma 2 comma 4. So the answer is false. Yes, S is this set, which is 1 comma 2 comma 4 6 8 10 50, and this is a subset. This is another set, 1 2 4. So what we are checking for, whether S is a subset of this set, which is not true, which is false. On the contrary, if I check for a superset, whether S is a superset of this, I hope you must be understanding. So S is my this set, and I am checking whether this S is a superset of this 1 2 4, which is true. So the output should be true. Yes, the output is true. Okay. So this is how you can make use of the different methods. Then you can perform the union. You can do other stuff. For example, let me do a union of this s dot union, and s should be union with this. And let me add one more element 5. What should be the output? I'm taking the union of S with 1, 2, 4, 5. What should be the output? Chalo, please tell me the output fast. Just 5 will be added. Okay, just 5 will be added means whatever is the content of S, 5 would be added to that content, right? Let's see. So yes, earlier we had 1, 2, 4, 6, 8, 10, 50 into S. And now into the another set we had 1, 2, 4, 5. So 1, 2, 4 was already there. 5 is the only difference value, so that would be added. Okay. And likewise, if I check for intersection, then what would be the output? What would be the output for this? H dot intersection 1, 2, 4, 5. What is the intersection between them? 1, 2, 4, 5. S is not change here. S is not change here. This set is the union of these two sets. This has not changed S. It has given you one new set, which is a union of these two sets, S and 1, 2, 4, 5. This has not changed, the set S. So into the set S, you still have only 1, 2, 4, 6, 8, 10, 50. Okay. And into this set, you have 1, 2, 4, 5. And so the output is 1, 2, 4. Okay. Because 5 is not present in the set S. So this is how you can perform different methods on your set. So set is mutable, but set is not subscriptable. You cannot do indexing on a set. Then the last one, important one, is the dictionary. See what happens at the end of a day, the widely used or the mostly used data structures out of these four are list and dictionary. Now, what is dictionary? Now, we already know what do you mean by dictionary. The way we have dictionary, the same way we have dictionary data type in our Python. So, if you think of dictionaries, what is dictionary? It is a collection of words with their meanings. I repeat, it is a collection of words with their meaning. Okay. So, in short, it is a collection of key value pair. I repeat, it is a collection of key value pair. Okay, you have a key, and then in dictionary, how the data is stored? Word, and then its meaning, like this. The word colon meaning. So we have data like this, and then the collection. So first word its meaning, then second word its meaning, then third word its meaning, and so on. This is our dictionary. In Python, the same thing we have. But now this word becomes a key because on the basis of that word only we search the dictionary. We check the dictionary. So this word becomes a key and this meaning becomes a value of that key. So we say that it is a key value pair. It is a key value pair. And then when you have a collection of such key value pairs, then it becomes a dictionary. Then it becomes a dictionary. So it is a collection of key value pair. And let me show you some help on dictionary. It's a class. Dictionary is not the name of the entire class. It's not working. Shit. Spelling mistake. DICT dictionary. Okay, so what all functions or what all methods we have in the class dictionary? Clear, copy, from keys, get items keys, pop items, set default, update values. And if I put a help on this dictionary, so it is giving you a help on the methods. New dictionary initialize from a mapping object. We are not interested into this. Okay, and before that, let me show you how to initialize a dictionary. For example, if I got a dictionary D, so dictionary is also enclosed in curly braces, but under these curly braces, the data elements are separated by comma only. So the elements are separated by comma, but now the element is a key value pair. Okay, so you have a key colon value. So key 1 value 1, comma key 2 value 2, comma key 3 value 3. And interestingly, your key values can be of different types. I repeat, your key values can be of different types. But all the keys should be of same type. If my first key is integer, then my all keys should be integer. If my first key is float, then my all keys should be float. If my first key is string, then my all keys should be string. Okay. For example, my key value is 1, and suppose my key is 1, and the value is suppose a string value. It is Ahmad. Then this becomes my key value pair, the first key value pair. Then second key, and the value is suppose Sachin. Then the third key, value is Vishal. So this declares our dictionary. If I see the type of D, so it is class dictionary. And there is a method called items. There is a method called keys. There is a method called get. Fine. So now, for example, if I say before going to those functions or those methods, if I want to make use of indexing into the dictionary, so in square bracket, I am required to give a key value. I repeat, I am required to give a key value. So for example, if I say D of 1, so let's see what do we get. We get a value of a key 1. Please see here carefully. We get a value associated with the key 1. Likewise, if I say D of 2, then we get a value associated with the key value 2. Likewise, if I say 3 of 3, then we get a value which is associated with the key 3. Okay. Do not misinterpret these key values with the index value. I repeat, do not misinterpret the key values with the index value. For example, if I try to see what is at the key value 0, D of 0, so it shows me a key error. What key error? That the 0 is not a key in the dictionary D. 0 is not a key into the dictionary D. Fine? That you need to understand. You can update your dictionary. You can update your dictionary. What does it mean? It is mutable or immutable? Let's suppose I want to update and I want to add a key value 0. Yes, it is mutable. So I would say key d dot update let's get a help on this. See carefully, d dot update, and then in square bracket we specify the value. Okay, then the first value is the key value, then the second value is the value itself. So how I would be updating? I would be updating like this: d dot update, and I want to add a new key 0. Fine. 0, and suppose the value is Manoj. We can update the already existing key value. The add method. For example, I want to update the value of a key 1. This is my entire dictionary. At a key value 1, we have Ahmad, then key 2, we have Sachin, then key 3, we have Vishal. Before this, what we were saying. If I want all the keys, I would be, so these are all the keys, and if I want all the values, then the method is, sorry, I want all the items. Then you have entire dictionary with all the items, and suppose I say 1. Let me check this. No, this is not a problem. Items do not take any argument. So this would return you the entire list, the dictionary. And if you want only the key values, then you can make use of the keys method. Okay, so the point is that you can make use of all these methods on your dictionary data. You can clear the dictionary, you can copy the dictionary, you can get form keys, you can get the data, you can get the items, all the items of the dictionary, you can get all the keys, you can pop the element, the last element would be popped from the dictionary. Then you can pop the entire item, you can set default, you can update, and then you have values also. So values is also there, which we missed. So this would give only the values. Dot keys would give only the keys, and dot values would give only the values. And your keys themselves can be of any type. Your keys can be integer, your keys can be string, your keys can be of other type also. But the point is that if your first key or is of specific type, then your all remaining keys should be of same type. Fine.